happy Sunday. George and I are here having pancakes. Well, George is having pancakes. I'm trying to make them. My boys love pancakes. I put chocolate chips in them, so things are getting a little sloppy. Hope you guys are having a great weekend. We're going to get into our first video here. Our first few lessons in our first module, we're going to be looking at patterns in multiplication on the place value chart. So it's going to be a great start to the school year. What we're going to do right now is we're going to look what happens to numbers when we multiply and divide them by values of 10. What is a value of 10, you may be asking yourself? We will learn that and we will work on it a little bit right now, and then I want you guys to come into class tomorrow prepared to practice and work and learn even more. So here goes nothing. Let's have fun here. Okay, kiddos, before we get into our first problem, I just want to remind you, hopefully everyone has their math notebook at home with you. If for some reason your math notebook did not make its way home, you can find a piece of paper in your house and set up your notes like this. That's totally acceptable. So everyone should have their math notebook at home. What I need your math notebook to look like is just like this. So we are in Module 1. We are in Lesson 1. And here we have video notes. That is the title for this part of your math notebook. If you have something above your video notes, that's totally okay. I just started on this fresh piece of paper. So if you're maybe starting at the bottom half of your paper, you can do one of those lines of learning to separate whatever was above. I guess what was above? Probably the last math problem we worked on, just to separate each part of your work. So we should have video notes. You're going to choose one problem to do along with me today. And then I also want you guys to make note somewhere in your video notes. Make note for the secret word, just to make sure that you can remember that for tomorrow. You'll have to check that in with our homework checkers tomorrow to confirm that you've watched this video. Keep in mind while I'm doing this work, you guys, at any time you can pause. If I'm going too quickly, you can pause and think about it. Or you can rewind and re-watch something. If something didn't quite make sense, you can pause, or you can rewind and have another listen at whatever I've said that seems a little confusing. Keep in mind, you are responsible for your learning here. You are responsible for your experience. So you have to constantly be assessing where are you in your understanding. After you finish watching the video, you should be pretty confident with what we've looked at. I want you to feel pretty good about it. So much so that you're able to come in tomorrow and practice this with me. So some of you might watch the video twice. Some of you might watch a few sections twice. So this is really up to you, and I really need you to assess, how do I feel about this? Does this make sense? Do I feel pretty good about this? So I want you constantly to be asking yourself that and kind of checking in with yourself. Okay, so I'm going to start the first problem. Here we go, guys. We are in officially M1 or Module 1, L1 or Lesson 1. Like I said, we are going to be looking at what happens to numbers when we multiply or divide them by powers or different values of 10. So we're going to start here. This first one has been done for you, but it's really it gives us some very critical information. So let's look and see what we have here. We have 3 and 452 thousandths, or 3.452 times 10. This is a place value chart. I think this is going to be very familiar for a lot of you. What I want you guys to remember as we're working with these place value charts, which we will be doing extensively in Module 1, is that the decimal, this black dot, I just drew another decimal, does not move. Decimals do not shift. Decimals are permanently seared right here on the place value chart between the ones place value and the tenths. The decimal, as you guys all know, separate decimal land from whole number land. The decimal does not shift. What does shift are the digits. Digits will shift around the decimal as we multiply them by 10 or divide them by 10. They will shift in a very specific way whether we are multiplying. When we multiply numbers, when we make copies of numbers, they get larger. So they're going to move here to the left on the place value chart. When we divide numbers, if I had a cookie and I was feeling generous and I said, hey, Sebastian, would you like to share this cookie? I would divide it, which would mean we would each have less. Well, really I have less because I had a whole cookie, but then I divided it and I'm sharing it with Sebastian. So I need you guys to really hang on to that knowledge that you already have. Remember, when we multiply, the numbers are going to get larger. When we divide, the numbers are going to get smaller. So larger, we're going to move here to the left. Smaller, they're going to move to the right on the place value chart. So here for the first one, we're multiplying by 10. Originally, we started with 3 point or 3 and, the decimal can be replaced with the word and, 452 thousandths. We're multiplying by 10, so we're going to move this away. And 10 has how many zeros? 10 has 1 0. So that means, I'm about to sneeze. Excuse me. Goodness sakes. 10 has 1 0. So each digit is going to shift to the left just one place value or one column because we're just multiplying it by 10. So we started off with 3.452, multiplied it by 10, which then resulted in each digit shifting to the left one column. So the 3 shifted right next door. The 4 shifted between the decimal world and into whole number world right here in our ones place value. 5 shifted from hundredths to tenths, and then our 2 shifted from thousandths to hundredths. So our result here was 34 and 52 hundredths. Okay, so now let's think about what happens when we multiply by another power of 10. We're going to multiply by 100. Keep in mind that 100 has 2 zeros. So let's put our original number. For those of you that are going to choose to do this problem along with me in your notebook, right now would be a good time to set it up. So we have 3.452, just like we had upstairs in that first problem we started with. We're going to multiply it by 100. So are the digits going to shift to the left? Or are the digits going to shift to the right? Will this number get larger when we multiply by 100? Or will it get smaller? Yes, thank you, Violet. It's going to get larger. The digits are going to shift to the left because we're making more copies. We're making 100 copies of this number. So the digits are going to shift to the left. How many place values or how many columns are each of these digits going to shift? Well, let's look up here. We multiplied by 10 and each digit shifted one place value to the left or one column to the left because there is 1, 0, and 10. Now we are multiplying by 100. 100 has 1, 2 zeros, which means each of our digits is going to shift, yes, to the left because we're multiplying. Each digit is going to shift 2 columns to the left because now we're multiplying by 100. So the digits are going to move 1, 2 columns to the left. So let's see what that looks like. So 3 started off in our ones place value. 3 is going to shift 1, 2 columns to the left, and it will land right here in our hundreds place value. 4 is in our tenths, but it is going to shift 2 columns to the left, which will land 4 in our tens place value. 5 is here in our hundredths to the right of the decimal. It is not a whole number, it is a decimal. It's in our hundredths, but it's going to shift 2 place values to the left when we multiply it by 100, which means 5 is going to land in our ones place value. And then don't forget our 2. We have 2 thousandths all the way down here. Please bring 2 along. 2 is also going to shift 2 place values to the left, which will result in 2 tenths. So our final answer here is going to be 345 and 2 tenths, which I will add to this line as the product. When we multiply 3.452 times 100, we will receive, or our final product will result in 345 and 2 tenths. Okay, so I want you to, in topic A, we're looking at patterns and multiplication. I want you to continue to analyze this pattern. What are you seeing? So we're multiplying 3.452 by increasing powers of 10. We started with 10, then another 0 was added and it resulted into 100, and then we added another 0 to the end of the number and that resulted in 1,000. So here we have 1 0, then we have 2 zeros, and now we have 3 zeros. So here we're going to multiply 3.452 again, and dearie me, I am out of space. I hope this turns out okay on your screen. My pen is being a little, there we go. So we are going to be multiplying 3.452 again, but this time we're multiplying it by 1,000. I want you to think about, how many zeros are in 1,000? 1, 2, 3. There are 3 zeros in 1,000, which means these digits are now going to shift 3 columns over, or 3 place values over. We're still multiplying, so are we going to be shifting to the left or to the right? Will this number be growing larger, or will it be, will the result be smaller? Well, we're multiplying. We're making copies of this number, so this number is going to be larger, which means we're going to be shifting to the left. We're multiplying 3.452 by 1,000. So each of these digits, keep in mind the decimal stays exactly where it is. The decimal stays exactly where it is. You can see that happening in all 3 problems. What is going to be shifting are the digits, okay? So we're not moving decimals at any point in 5th grade. We're moving or shifting our digits. So how are these digits going to shift? These digits are going to shift 3 place values to the left because we're multiplying this number by 1,000. The digits shifted 1 place value to the left when we multiplied by 10. The digits shifted 2 place values to the left when we multiplied by 100. And now that we're multiplying by 1,000, we're looking at a shift of 3 place values to the left. So I'm going to have to squeeze that in here. So our 3 ones are going to shift 1, 2, 3 place values to the left, which will result in 3 thousands. Okay, our 4 tenths are going to shift 1, 2, 3 place values to the left, which will result in our 4 tenths. When we multiply 4 tenths by 1,000, we will have a product of 4 hundredths now. Okay, so now our 5 hundredths, 5 is in the hundredths place value right now. 5 is going to be multiplied by 1,000. 5 is going to shift 1, 2, 3 place values to the left, and 5 hundredths is now 5 tens, or 50. Okay, 2 thousandths all the way down here is going to be multiplied by 1,000, which is going to mean that 2 thousandths is going to shift to the left 1, 2, 3 spots, which means that we no longer have 2 thousandths, we have 2 ones. So when we multiply 3.452 times 1,000, our final product is 3,452. The digits are shifting. In these problems, all of our digits are shifting to the left because we're multiplying. We started with 1 jump to the left with 10, and we ended with 3 jumps to the left when we multiplied by 1,000. Okay, kiddos, we are going to check out another problem that has 3 parts. And I want you guys to think about that big difference. We've talked about this already. When we multiply a number by a power of 10, or when we divide a number by a power of 10. When we multiply something, we're making copies, so the number is getting larger. When we're dividing something, we're breaking it up into smaller equal pieces. So the resulting quotient is going to be smaller than what we started with. So here we have 345. We're dividing 345 by 10. We're dividing 345 into 10 equal pieces. The result is 34.5, meaning we're going to have 34.5 in each of our equal pieces. So 34.5 is much smaller than 345. I just need you guys to be very critical of the operations. It's that's so important. So here in these problems, we're dividing. Our previous problems, we were multiplying. So now when we're dividing, you can see these digits are shifting to the right because our numbers are going to be smaller. We're dividing them into smaller pieces. We're going to do exactly what we did before. We're going to look at these powers of 10. So we're dividing by powers of 10. Powers of 10, the powers of 10 are increasing. So I want you to think about what's going to happen when we're dividing. Here we're dividing into 10 equal pieces. Here we're dividing into 100 equal pieces. And here we're dividing into 1,000 equal pieces. So I want you to think really critically about what's going to happen with our quotient. So our quotient here when we divide by 10 is 34.5. I want you guys just to make some observations, take just a moment to think about what will our resulting quotient be here and here. Here we're going to be dividing by 100, and here we're going to be dividing by 1,000. So just take a moment to make just a quick prediction about what our quotients are going to look like. Cool. Okay, so we talked about already, and I'm going to continue talking about this, and you're probably going to get sick and tired of hearing me say this. I want you to remember that our decimals are going to stay here. Our decimals are not going to shift. What you will see shifting are the digits. The digits are going to be shifting around the decimals. The decimals are going to stay put. Think about them being permanently seared here. We are not shifting decimals, we are shifting digits. So we started here in A. This one has been done for you, obviously, with 345. We divided by 10. How many zeros are in 10? Just 1. So that means that we're dividing by 1 power of 10. We're just dividing by 1/10. So each of the digits shifted over 1 place value. 3 was here in hundreds, it ended up in tens. 4 was here in tens, it ended up in ones. 5 was here in ones, and it ended up in tenths. So 345 divided by 10, each digit's shifting over to the right because we're dividing 1 place value. Our resulting quotient is 34.5. Again, the decimal place stayed there. So now let's look at what happens when we divide 345 by 100. We're going to divide 345 by 100. Think about how many zeros are in 100. 1, 2. You can see very quickly there's 2 zeros in 100. That connects us to the amount of shifting in our place value chart. We are multiplying by, let me break that down for you a little bit, 100. Yes, there's 1, 2 zeros in 100. Also, 10 times 10 is equal to 100. So we will continue kind of expanding on this, but I just want you to think about powers of 10. We're going to watch a really interesting video tomorrow in class about the powers of 10 and what happens when you multiply 10 by itself multiple times. That's where we get this language, the powers of 10. The powers of 10 essentially means that we're multiplying 10 by itself. And we're going to eventually look at some different forms of 10. So 10 times 10 is equal to 100. I think a lot of you are comfortable with that. 100 is also equal to 10 to the second power, which means we're multiplying 2 tens together. So we can absolutely connect what's going on in our place value chart to the work around powers of 10 or values of 10. Okay, so for now I want you to think about the fact that there's 2 zeros in 100, which means that each of our digits are going to shift to the right 2 place values. We're shifting to the right because we're dividing. So our 3 is going to shift 1, 2 place values to the right. So our 300 is now going to be 3 ones when we divide by 100. Our 4 tens is going to shift 1, 2 place values to the right. So it was 4 tens, but now it's 4 tenths. And our 5 ones is going to shift 1, 2 place values to the right, which is going to result in 5 hundredths. This place value is hundredths. So 345 divided by 100 results in a quotient of 3 and 45 hundredths. Very cool. Okay, let's look at this Let's look at one more problem down here. We are still starting off with 345. This time, however, we are dividing by 1,000. Let's think about what that really means. We're dividing by 1,000. I'm just going to kind of expand upon that for you. And let's think about the fact that 10 times 10 times 10 equals 1,000. 1,000 is also equal to 10 to the third power. This floating number here, and we're going to learn a lot about this, is called an exponent. And this floating number says that we're going to multiply 3 tens together. So all of this work here results in the same information. 1,000 can be expressed in a few different ways. The reason why I'm even touching on this right now is that I want you to connect this with our place value chart. We're dividing by 1,000. So what we're going to be doing is shifting our digits over to the right because we're dividing. We're going to shift our digits over to the right 3 place values because we're dividing by 1, 2, 3 tens essentially. 1,000 is equal to 3 tens being multiplied together. So our 300s is going to hop over 1, 2, 3 place values to the right, which is going to result in 300. When we divide 300s by 1,000, we're going to end up with 3 tenths. Now we're going to divide 4 tens by, I'm sorry, did I say by 100? I meant to say by 1,000. We're going to divide 4 tens by 1,000, which means this digit is going to shift 1, 2, 3 spots to the right, and we'll end up here in tenths. Our 5 ones are also going to hop 1, 2, 3 place values to the right, and we will result in 5 thousandths. So 345 divided by 1,000 is equal to 345 thousandths, or 0.345. Secret word. I'm sure you guys have been on the edge of your seats waiting for this. The secret word is whatever I made for breakfast this morning. Think about the beginning of the video. I was in the kitchen with Georgie and I said, oh, we're making blank for breakfast. What did I make for breakfast? Whatever I made for breakfast this morning is our secret word. If you've forgotten what I made for breakfast, please rewind and watch that part again. Bring the secret word in tomorrow and enjoy your Sunday. Get lots of good rest tonight because we are going to come into the classroom and really work hard. It's going to be a wonderful week. I'm so excited to see you guys tomorrow. Hope you enjoyed your first video. Way to go, guys.